Hello, today we're talking about the area of rectangles. And the fun little expression phrase of the day is, it's what's on the inside that counts. And you'll see today that that's exactly what you'll be doing, counting what's on the inside. And evil chuckle is inserted here. Ha, 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 ha. At any rate, we're going to start with a term. We have one new term for today, and that new term is area. And we could define area as well, the area of a figure is the number of square units that the figure encloses. So that would be area. And important to get that recorded in the vocab section of your binder. The goal for the day is to come up with a formula that we can use to find the area of any rectangle. We're going to go through an activity that will hopefully lead us to arriving at a formula for the area of a rectangle. Again, area, the amount of surface a figure covers. Area is different from distance in that measures like the base, height, even perimeter. So we've talked about base, we've talked about height, we've talked about perimeter. Area is going to be different than those measures in a couple ways. This should be recorded in the notes section of your binder, and it's the amount of surface that a figure covers cannot be measured with units of length. To figure out how much surface a figure covers, it's necessary to use square units. So we're literally going to be covering a surface with squares to see how many square units that surface encloses, or that figure encloses. If a rectangle has a base and height measured in meters, its area would be measured in square meters. The abbreviation there you can see is meters to the second power. That's how it would be written, and we'll read it as square meters. If the base and height are in inches, its area would be in square inches. And again, the abbreviation would be inches to the second power, but we'll read that as square inches. We could extend that and talk about, if your base and height are measured in miles, you're talking about square miles. If your base and height are measured in millimeters, you're talking about square millimeters, base and height. In whatever other unit, then that the area would be in square units thereof. All right, so the figures. Okay, so the figures on the next slide are shown on a grid, and each square is one square unit. So we can find the area by counting the number of squares that the figure covers. And again, that's how we would tell that figure's area. So some simple figures, and again, we would just count. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the area of this green figure would be 16 square units. We use square units, because the dimensions of the figure are not labeled with a measurement. We don't know if we're talking about inches, centimeters, miles. We don't know what it is. And the same thing here with the pink figure. We just count the number of squares that the figure encloses. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the area of this pink figure would be 15 square units. Again, we're going to do the same thing in the little activity that we're going to do next. So we got the idea of area. We're going to explore the area of rectangles. You'll find online a rectangle area worksheet or activity, and it features 8 rectangles. What you're going to do is you're going to record the dimensions of the rectangles, and you're going to count the area of the rectangles. You're going to put all that information in a table, a spreadsheet. You'll then upload that spreadsheet to the Moodle, but that's irrelevant. We're going to use the table to try and establish a connection between the dimensions of the rectangle and their area. And that's really the goal, is to look at the base and height of a rectangle, and then try and figure out what's the connection between the numbers and the area that we're finding. So we'll do the first example together. Here we have a rectangle that you may want to call some other kind of figure, but it is a rectangle. We're going to start with the base, and again, the base is a length. So we're going to count the lengths here. We've got 1 length, 2, 3, 4, 5, 6, 7. So the length of the base is 7 units. And again, I wasn't counting squares there, I'm counting lengths, and that's an important distinction to make. When we're talking about area, when we're talking about base and height, those are lengths, not area, and lengths are measured in standard units. So next we're going to talk about the height, and the height, again, must be perpendicular to the base. And we've got 1, 2, 3, 4, 5, 6, 7 units is the height, so our height is 7 units. So the last thing we're going to do here is we're going to count the area of the figure. Again, base and height were lengths, so we counted the lengths, but area is measured in square units, so we're going to count the squares here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49. So the area, 49, and now we're talking about square units because we're talking about an area. So 49 square units, the area of the figure. And again, your job now is going to be completing or doing the same activity to fill in the table that you'll find online. Again, you're going to fill in the table, and then we'll talk about what we're going to do with that table. That's it for now.